In this video, we are going to introduce the idea of an indefinite integral. Now, we've already talked about antiderivatives. We've talked about integrals. So why would we need to talk about something called the indefinite integral? Well, it'll help to think about what each of these three things means. So an antiderivative is just one particular function. So it is a function, f, capital F, whose derivative gives us the function little f that we wanted. So it's a function capital F so that f prime equals the function that we're interested in. So what is an integral? So far we've talked about the definite integral from a to b of some function little f. And what this is, it represents an area. Specifically, it's the area underneath the curve bounded either above or below the x-axis between a and b. So actually our answer here, or whatever we get out of the integral from a to b of f of x dx, is going to be some number. It's a number representing the area. Then what is this indefinite integral? It's really just a nice way of writing down this whole family of functions, capital F, whose derivatives are all the function little f that we are interested in. So if we took the definite integral of those families of functions, then we would get an area. So an indefinite integral would be written in this way, and it represents a family of functions. So we get a whole family of functions so that each one of their derivatives is equal to the function that we are interested in. And it turns out that each one of the members of this family of functions is some vertical shift of each other. So you'll remember when we talked about antiderivatives that we had to add that c, that constant c, because the derivative of any constant is 0. So what these family of functions are, they are all just vertical shifts of each other. We'll look at one really quick example. Since we've already talked about antiderivatives, it doesn't get super complicated. Let's look at this example here, where we need to take the indefinite integral, not on any certain bound, but the indefinite integral of this function. First, we'll expand it out. So we'll have integral of 2t squared plus 4t plus 8t plus 16 dt. This is going to be the integral 2t squared plus 12t plus 16 dt. And you know how to take the antiderivative of this, so you actually know how to take the indefinite integral of this. That would be 2t to the third divided by 3 plus 12t squared divided by 2 plus 16t. And we can't forget that constant that we need to add, because you know that if you take the derivative of that constant, you'll get 0. And we can just simplify one more time. 2t to the third over 3 plus 6t squared plus 16t plus that constant c.